Alright, here we go, live homework help. If you need help with your homework, now's the time to ask your questions. Feel free to do so via the chat function. My computer will beep at me, letting me know that you have chatted. Don't worry, it won't show up on the screen. I wonder why he doesn't do that. Let's think about that for just a minute. Alright, so here we go. And we'll assume the technology is going to behave itself. Please be aware I will answer any question in the high school GED curriculums, as long as I am not forbidden by policy, etc. Because we do have some questions I'm not supposed to teach about. And if you manage to stump me, you'll be like the rest of the world asking me, okay, sir, what do you want? Oh, no, I stood in line. It was what everyone else did. Well, you're at the front now. Decide what you want. All right, Ruth Ellen, your question was on 6.2, I believe. I believe I told you that's a beautiful thing that you were asking about. Ooh, it is. Funny how that works. X over 3 plus x over 2 is equal to 5 over 6. Well, that looks fun. Okay, so I've run into an evil fraction. They have different denominators. What's my first step? Prime factor denominators. So I know this is x over 3 plus x over 2 is equal to 5 over 2 times 3. So I prime factor my denominators, always my first step. It doesn't matter if there's alphabet soup in it or not. This is different than what we do, but this is the same direction. This is why I teach it that way. Next, we will declare our LCD. And so for that, I'm going to pick on whichever one I want. Doesn't matter, 3 or a 2 or a 2 times 3. Always go for the one with the most terms because chances are it'll clean up nicely. So 2 times 3. Now, if I were doing a regular addition problem, I'd be worried about using, the whole identity property. But this is algebra. There's an equal sign. Oh, joy. So instead what I'm going to do is I'm going to multiply every term by my LCD. And the reason for that is multiplication distributes across addition or subtraction. In this case, we have right here, this is addition. So I've got to distribute that across. I'm multiplying both sides by the same amount, in this case 6. My LCD is equal to 6. When I do, I'm just going to take, and anywhere there's a 2 top and bottom, 3 top and bottom, I'm done with that. 2, 2, 3, 3. I get 2x plus 3x is equal to 5. Are we okay with that? Now I combine like terms. I get 5x is equal to 5. Stop skipping steps. Not the rest of us are fast. What if I don't know that? What if you just made my head hurt? Like, you're not supposed to be doing advanced math right now. Come on. She is correct on that. I'm just having fun. With this, we can use the multiplication property of equality to divide both sides by 5. And when we do so, we get x is equal to 1. That is 100% correct. But just to be sure, I can take, and from there, check my answer by plugging it in. And when I do, I get 1/3 plus 1/2 equals 5/6. And I know that's true because that's one of my favorite fractions to add. If you're not sure about that, yeah, that's up there. That's one of my favorites. Think back to me making you tear paper. Oh, horrible memories. Yeah. Isn't that cool? I'm happy about it. I don't know if everyone else is. All right, Daniel, you brought a question to us today?
Yeah. It's about adding unlike fractions.
Perfect. So do you have an example, a fraction you'd like to see worked out?
Yeah, let's see. Let's do 2/5 plus 2/7.
Now, one of the mistakes some people run into is they get so used to clearing fractions. We'll run into this and we forget the skills that we've already developed. And so it'll cause us a little heartburn. Notice there is no equal sign here. It's not set it to equal to anything, see? It wants an answer. It doesn't have it set equal to something. We can't apply some of the properties that we did on the last problem. So instead what we're going to do is do our algorithm for adding fractions with unlike denominators. Step 1 is prime factor denominators. So we prime factor them. 5 is factored and 7 is factored. Step 2, we declare our LCD. So they both have the same amount of factors. Which side do you want to pick on, left or right? Sounds good. So we're going to write a 5 here. And what I'm doing right now in my brain is I'm going, okay, and I'm just going to switch to the magic pen. I've looked here, and there's a 5, right? Now, in my brain, I'm also going, what's over here? Whoa, hello. Stop it. Go away. Hey, did I break you? Ah! The magic pen will not leave me be. I broke it. It's normal and not so persnickety. So now I'm going to take, close, thank you. Now I'm going to take and look up here at this spot here, and what's missing? Well, I don't have the 7. So my LCD is 5 times 7. Now I'm just going to put some parentheses up here because parentheses represent multiplication. And I'm just going to draw a line here. So I'm going to look here. Right here, I need to put something in right there. I've got a 5 here. What do I need to put in? 7. Over here, I have a 7. What do I need to put in here? 5. Now, am I done? Can I put a 1 here? Right, because I'm using that identity. Any number divided by itself is equal to 1, except for that number can't be 0. Never divide by 0. If you do, I'll come haunt you. With that in mind, I get 7 times 2, which is 14, plus 2 times 5, which is 10. All of that is over our LCD. 14 plus 10 is equal to 24. Now I'm just going to factor that down into primes. So if I do, I can pull out a 2. That leaves me with a 12. So that's 2 times 2 times 2 times 3 over 5 times 7. Can anything be reduced out? So at that point, I just combine it, and I get 24 out of 35.
That's how I had it, but I was really confused because if I do it like, if I only multiply 5 by 7 and then add 2, I have different answers. That was my question. You always have to multiply it by their factor.
Yeah, you're going to get them the same size pieces when we were folding paper and we added the 1/2 plus 1/3. Do you remember we had to fold it into 6 pieces so we could see how well it lined up? It's the same thing here. We're just cutting it into the same amount of pieces so the denominators are the same and I can tell exactly how much I'm dealing with. You know what, I can tell you this. It's hard when you get back on a Monday and you get started. And sometimes you may feel like, hey, I had this and then I lost it. There's power in the struggle. Just go through it. The biggest thing is to start writing down your algorithms and your definitions and get there. If you've got those, you'll get it. And even if it feels a little awkward, you can always come and we'll look at it, we'll work through it. This is not stuff that comes second nature for most people. But if you get used to it to a point where it's second nature and you can tell me the steps, you'll get right answers. Did you have another question? Yeah. Okay. Number 49. Okay, what are we looking at? 20 minus z over 3 is equal to. Sounds like a lot of z's going on there. Okay. So on this, my first step is clear fractions or decimals. Clearly that's annoying, right? I don't like those fractions. They aren't doing anything for me. What have they done for me lately? Nothing. All right, well, let's have a look at the LCD. What is my LCD? So now I just multiply every term times 2 times 3. Hello. And when I do, I get because anywhere it's the same top and bottom, I just cross something out. See how much more beautiful that is? That's a lot happier, isn't it? It is. You okay with it now, or would you like to see it continued?
So now I combine like terms?
Well, I can't combine like terms because there's nothing that's the same on both sides, but I can use addition property of equality.
I will take the 2 away.
And now I'm going to use the old multiplication property of equality. We will not have class on Thursday, in case I didn't mention this online earlier. I will be at a training. No, Monday is Martin Luther King's birthday. We celebrate it, yeah, in style. I'm not sure.
So,
It's around his birthday. It's Martin Luther King Day.
So it'll be like from Thursday all the way to.
Well, I'll be in here on Thursday. I'll just be a little later. They've scheduled a 3 o'clock training that as a teacher I will be attending.
Will be open.
Oh yeah, everyone will be here, except for me.
Okay.
And I'll be here after I'm done with said training. We're just, for people working on a GED, it's not as big a deal, but we're implementing some changes to our high school setup. And with that, I want to be on the pioneering end of it for the state and for our district. So there's some things we're doing that I believe will make it a better setup to serve my students. So this training's about the technology involved. And this is where I get to bug the people at the district office and ask them a million questions. This is when they can't tell me to go away or shut up. It's so awesome. But my boss will be there, so he'll tell me to go away and shut up. Right? He'll be like, Matt, they get it. They get it. No. I have not finished. Hear me roar. Okay. So there we go. Are there any other questions that anyone would like to see worked out? I'm going to give people at home 1 minute. If you haven't done so, posted a question in the next minute. Yeah. We'll go on, and you can always email it to me. 41. I would love to do number 41. What is 41?
6 equals -4.
Ooh, that's happy. What it is? I'm sorry. Okay, sorry. Please. 6. Ooh, that's pretty. Okay, so my first step when I'm solving these linear equations, or in this case it might be no, it's not very quadratic. When I'm solving these equations, my first step is to clear fractions or decimals. There are none. Combine like terms. There are none. Ooh, that distributive property. Look at it sneaking in. The step I always forget to mention. So I'm going to distribute because multiplication distributes across addition or subtraction. I get 6 equals -4 times 1, which is -4. -4 times x is positive 4x. And then 3 times x plus 3x. 3 times 1 is 3. Now I'm just going to combine like terms. I'm going to get 6 is equal to, and I'm going to get -1 plus 7x. Ooh, I see where this is going. I'm going to add 1 to both sides. And I get 7 is equal to 7x. Ooh. Multiplication property of equality. 1 is equal to x. Haha, my x is alone. There's only 1. See? Beauty. Happy. Gotta love it. The chance to distribute. I would love to look at this. What am I looking at?
I primed it out and got this, and then what do I do?
Okay, so now let's use the addition property of equality.
And take away the 3?
Well, we can do that for sure. And
Or do we want
yeah, we're just getting them to the same side, so minus 3y and minus 3y. Because we can add the opposite. 2y plus 6 equals,
-6.
and now let's get that 6 away from our 2y. There we go, getting happy. 2y is equal to negative 12. Minus 6 here.
That's negative.
Yeah, negative, and you minus here, you minus there. There you go.
And y.
Is equal to negative 12. There you go. See, isn't that happy? All right, I'm going to go on ahead and wrap up the live stream. I am still here to answer questions. For anyone at home, have a wonderful day. Don't work too hard. You know, that usual stuff that we talk about.